Then what? What's the punchline here? Then the image, I think I was assuming the spaces were simplices in my previous comments, George. But as I said, that's one of my principal vices, so you shouldn't be surprised. Spans a simplex of L. I see what you're saying, Daniel. There's no expectation of
The reverse nature.
yeah. Of course, repetitions among the images are allowed. Theorem. If sorry, my script EK is needing work. Consists of all what? Simplicial complexes. All simplicial complexes. And all simplicial maps, then what? With the usual composition, then K is a category. And underlying defines a functor. So the objects.
The objects are the
Complexes,
right.
and the morphisms are the simplicial maps, I guess.
Right. So then the functor takes those to the underlying space, and this induced map they talk about with the.
So he says for each. Is it for each S and K? This one. Define F sub S from S to the underlying space of L as the affine map determined by the restriction of the simplicial map to the vertices of S. Well, he's before this. He's defining the whatever this is for each simplicial map. For phi simplicial map. He's defining the underlying map, I guess. Map of underlying spaces. How's he doing that?
What he's describing.
For each simplex in K, you define a map F sub S that goes from S to the underlying space of L according to looking at the restriction of the simplicial map from, well, the restriction of the simplicial map to the vertices of S. Okay. Yeah.
And then we used to gluing lemma to kind of stick them all together.
Right.
That's possible because.
So you're defining it on sort of a I don't want to say basis set, but it's kind of that. I mean, the whole thing is formed from these convex combinations of the vertices. So if you define it on these.
And if we know that they match on the overlaps, then we're good.
Gluing. Back to the gluing lemma. The gluing lemma. So that assembles a unique continuous function from the underlying space of K to the underlying space of L denoted by underlying phi, that we have defined a functor is left as an exercise for Nathan. Very good. Let's see. Sorry, Nathan. I'm misbehaving slightly. So anyway, definition. A map of the form underlying phi from K to L, where phi is K to L's simplicial map, is called piecewise linear. All right. So basically, what he's saying is, by definition, the thing we did in this construction is called a piecewise linear map. All right. He says there's no obvious functor from top to the simplicial complexes, even if we confine our attention to the subcategory of polyhedra. Given a continuous map on the underlying spaces, it may not even be true that F is equal to the underlying map of some simplicial map. After all, there are only finitely many simplicial maps, but we are flexible. Is it true that F is homotopic? Is that homotopic? What's that mean?
Yeah, that's homotopic.
Is F homotopic to the underlying map of some simplicial map? Oh, answer still no. Here's a counterexample. We shall subdivide K with the same process as in the proof of excision to obtain more and better approximations by simplicial maps. Oh, it's about to get nasty, isn't it? What's his? Oh, here's his definition. So let K and L be simplicial complexes. Phi, the simplicial map. F be a map from underlying space of K, underlying space of L continuous. Then phi is a simplicial approximation to F if for every vertex P of K. Is that? Oh, that's star. The image of the star at P is the star of the image of P under the simplicial map. So he says it's easy to see that the underlying map on the star at P is a subset of the star of the simplicial map at P. So what we're saying is that F behaves like the underlying map of the simplicial map, in that it carries neighboring simplices of P, simplexes of P rather, inside the unit of simplexes near the image of P. Man. Alrighty. So we'll pick up back here on page 138, give or take. Next up, varicentric subdivision. The mesh is back. And hopefully I will actually get to, we'll see where I get to next time, but we'll just keep working our way through here and we'll get there in due time. Although I think we may take a break from topology next week to do research, because the time to get takatik. So I'm going to try to work on the, we'll come back to this probably week after next. Is it Thanksgiving? No, I don't know. But I want to take next week to try to edit, fix, and so forth and so on the research that we've done. So.